Regulatory perspective and drilling centers on one key message. Casing is not just a drilling component. It is a primary part of the well barrier system, and it must demonstrate pressure integrity, formation isolation, aquifer protection, and long-term containment.
That framing matters because the regulator is not only asking whether the casing looks adequate on paper, the regulator is asking whether the well can remain safe, controlled, and environmentally protective throughout its intended life.
The first regulatory point is design compliance. Casing design must be supported by engineering calculations, load cases, material selection, design assumptions, and safety factors. That means collapse, burst, and tension are not abstract design checks. They are evidence that the casing can withstand expected mechanical and pressure loads without compromising containment.
And that connects directly to risk management.
Exactly. Under the Victorian petroleum regulatory approach, the operator must show that identified risks are managed and that loss of containment is prevented. The casing program is part of that demonstration.
From the top of the well, surface casing has a clear environmental function. It protects shallow formations, especially groundwater and freshwater aquifers, from drilling fluids, hydrocarbons, and other formation fluids.
That is not optional.
Correct. Surface casing also provides structural support for the wellhead and establishes the foundation for later casing strings. But from a regulator's viewpoint, the decisive issue is whether protected water bearing zones are effectively isolated. If that isolation is inadequate, the well may create a pathway between an aquifer and deeper formations. That is where well integrity becomes environmental protection.
So the casing is both structural and protective.
The next layer is intermediate casing. Its role is to isolate problematic formations, manage pressure transitions, and reduce the risk of communication between zones with different pressures or stability conditions.
That is where pressure management becomes part of the casing decision.
Yes, the drilling fluid provides hydrostatic pressure during drilling, but the casing system must provide a more permanent structural and hydraulic control point once installed and cemented. A regulator would expect the intermediate casing string to be justified against the anticipated pressure environment, formation behavior, and well control requirements.
Production casing then becomes part of the permanent well barrier architecture. It provides long term isolation around the producing interval and supports completion and production operations.
But the casing alone is not the complete barrier.
Precisely, the cement sheath is essential. It provides hydraulic isolation behind pipe and helps prevent unwanted fluid migration between formations. A casing string may be correctly specified, but if it is poorly cemented, the intended barrier may not exist in practice.
That distinction is central to regulatory thinking.
It is why centralization, cement placement, pressure testing, and cement evaluation where required are not administrative details. They are verification activities that support barrier assurance.
Installation practices also matter before cementing. Running speed, casing fill, makeup torque, thread condition, drifting, and inspection all influence whether the casing reaches depth in the required condition.
And those details become evidence.
Exactly. The regulator needs confidence in the design and in the execution. That confidence comes from records, calculations, assumptions, casing tallies, pressure tests, cement records, and verification results. A record retention is therefore part of compliance. It allows the operator to demonstrate that the barrier was designed, installed, and verified.
The wider well control system supports that barrier framework. Blowout preventers, accumulators, choke manifolds, wellheads, valves, and pressure control equipment provide operational control while casing and cement barriers are being installed, tested, or exposed.
They are not substitutes for casing integrity.
Correct. They are supporting controls. The casing and cement system must still perform its own isolation function, especially across aquifers, pressure transition zones, and producing intervals.
Drilling fluids also fit into this view. Mud weight supports pressure control, cuttings transport, wellbore stability, and formation protection during drilling.
But once casing is run and cemented, the regulator looks for permanent barrier assurance.
Which brings the assessment back to three questions. Was the casing system designed appropriately? Was it installed and verified correctly? And is there sufficient evidence that it continues to perform its barrier function?
The central takeaway is that casing design is a barrier management decision, not only a drilling design decision.
Strong casing, effective cement, verified isolation, and protected formations are the foundation of a defensible well integrity system.
In regulatory terms, the well must demonstrate containment, aquifer protection, pressure integrity, asset protection, and compliance through both engineering design and retained evidence.